Hello friends, today let us learn about rational numbers and irrational numbers. In this video, let us try to distinguish between rational numbers and irrational numbers. Before that, we must know some basic types of numbers. So let's start with that. That is the types of numbers. First type is the set of natural numbers. Natural numbers are also called as a counting numbers as they are used for counting objects like 1, 2, 3, 4. These are the numbers which are used for counting objects. That's why they are called as counting numbers or natural numbers. If we add 0 to natural numbers, we get whole numbers and the set of that is denoted by a letter W. The next type is set of integers, that is all the positive numbers, all the negative numbers and 0. If we collect all these numbers, they are called as integers. So these are the three basic types of numbers. So these are the three basic types of numbers. Based on these, we are going to learn rational numbers and irrational numbers. Now there is another type which covers all these types of numbers, that is called as a real number. So if you consider any number, it can be classified either rational number or irrational number. And if we collect all the rational numbers and irrational numbers, we get a set of real numbers. If we consider any number, either it can be a rational number or irrational number. These two numbers are different from each other. We are going to learn how to distinguish these two numbers, but before that we must know these two concepts, that is the rational number and irrational numbers. So let's start with rational numbers. Rational number can be defined as any number in the form p divided by q is there where p and q are any integers and q is not equal to 0. Q is not equal to 0, then p divided by q is called as a rational number. Or in simple words, any number in the form of numerator and denominator is a rational number. Only condition must be supplied here that q must not be equal to 0. For example, 2 divided by 3 or minus 7 divided by 11 or minus 25. So these are the some examples of rational numbers. Now you might think that minus 25 is an integer. Though it is an integer, it can be also treated as a rational number because any number in the form p divided by q is a rational number and minus 25 can be expressed as minus 25 divided by 1. So that's why minus 25 is also a rational number. Rather, any integer or any whole number or any natural number is a rational number because they can be expressed in the form of numerator and denominator. Now let us have one example of a rational number, that is 13 divided by 5. We can write this in the decimal form also. To do that, we have to divide 13 by 5. So we'll divide 13 here by 5. If we divide 13 by 5, we get 5 2s are 10. So if we subtract 10 from 13, we get the answer 3. Now here, 3 cannot be divided by 5 as it is smaller than that. So we should add 0 on 3, and for that we have to take a decimal. Now if we divide 30 by 5, it's 5 6 are 30. So here 30 is subtracted to get the remainder 0. So in this division process, as we can observe, we get a remainder 0. That means the division process ends here. That is, the division process terminates and we get the division as 2.6. So 13 divided by 5 can be also expressed as 2.6, which is the decimal form of 13 by 5. And in this case, as we can observe, the division process terminates or it ends. That's why this type of decimal form is called as terminating. By observing this decimal form, we can decide whether the given number is a rational number or not. So if the decimal form of a number is terminating type, then it is a rational number. Another example of terminating decimal form, that is 29 divided by 16. If we divide 29 by 16, we get 1.8125. In this case also, the decimal form is of terminating type. We have another example, 17 divided by 136. This decimal form is also terminating type. Now let us have one example, 2 divided by 11. So if we divide 2 by 11, we get 0.181818 and so on. That is, in this decimal form, we never get a remainder 0 and the division process never ends. And we get a group of number that is 1818 all the time. So 0.18, this group of number is coming again and again. That's why it is called as a recurring and it is denoted by 0.18 bar. So this type of decimal number, though the division process does not end here, but we get a group of numbers again and again. It is of recurring type. Such a decimal form is called as non-terminating recurring type. Though it is not terminating, but the same group of number is recurring. That's why it is called as non-terminating recurring type. Let us have another example. If we divide 11 by 6, we get 1.8333 and so on. So here, as we can observe, 3 is repeating again and again. In this case also, in 1.83, 3 is recurring. That's why it is represented as 1.83 recurring. So this form is also non-terminating recurring type. So if we have the decimal form either terminating or non-terminating recurring type, then that number is called as a rational number. So these are all the examples of rational numbers by which we can decide whether a given number is a rational or not by having its decimal form. Now let us come to irrational number. Now let us have an example. If we have to find the square root of 2 by our conventional method, we find the square root of 2 as 1.41421 and so on. If we observe this decimal form, that is 1.41421 and so on, in this decimal number, no number or a group of number is recurring and this process never ends. That's why such type of decimal form is called as non-terminating and non-recurring. That is, it is neither terminating nor recurring. That's why the decimal form of root 2 is non-terminating and non-recurring. Let us have another example. Let us have the square root of 3. So if we try to find the square root of 3, we get here root 3 is equal to 1.732 and so on. In this case also, this decimal form of root 3 is again non-terminating and non-recurring. So if there is such a decimal form of a number which is non-terminating and non-recurring, then that number is called as irrational number. So root 2 or root 3, these are irrational numbers as the decimal form is non-terminating and non-recurring. So by using this, we can identify rational number. That is, for a rational number, if its decimal form is non-terminating and non-recurring, then that number is called as irrational number. So by this now we can distinguish between rational numbers and irrational numbers as if there is a number whose decimal form is either terminating or non-terminating recurring, then such numbers are called as rational numbers. So here 0.18 bar or 1.8125. So for such numbers, decimal form is either terminating or non-terminating recurring. That's why these numbers are called as rational numbers. And from this we can define rational numbers as if the decimal form of a number is either terminating or non-terminating recurring, then the number is a rational number. And on the contrary, if the decimal form of a number is non-terminating and non-recurring, then such numbers are called as irrational numbers. And by this we can define irrational numbers as if the decimal form of a number is non-terminating and non-recurring, then the number is irrational number. So by observing the decimal form of a number, we can decide whether the given number is a rational number or irrational number. So this is the way by which we can distinguish between rational numbers and irrational numbers. Hope you understand this concept. Thanks for watching.